Welcome. This project by Abel Rossa and Tyler Nicholson is about creating mathematical models to explain the real world. Economics is overflowing with mathematical models. While all models are simplified versions of the real world, one common model bothers me. During the Cold War, countries got grouped into first, second, and third world. When the label third world became an insult, economics adjusted and now uses the labels developed and developing. Grouping all countries of the world into only two groups has limited value. If used appropriately, those groupings are fine. But like many economic concepts, simple grouping tends to be used in completely inappropriate ways. Well-meaning educators attempting to explain complex ideas in an understandable fashion are often guilty of employing techniques that would add to the confusion. Different countries all have unique economic systems. Even when a country attempts to photocopy the exact system of another, as the Philippines attempted, the result is not a carbon copy. This is how the Georgia Performance Standards address the issue. The implementation of this most often takes the form of directing students to memorize a table. A table something like this. Why this method is often used is understandable. This method is easy to teach, the burden is completely on the students to memorize the details, and the teacher needs little to no understanding of the details to be able to teach this method. Of course, there is rather large disadvantage of this method affording no opportunity to explore the economics or the mathematics of answering how to classify systems in the real world. In addition, retention is unlikely, given the abstraction and the disassociation from the real world. What is worse, even in authoritarian North Korea, black markets are everywhere. No economy on the planet, no matter how remote, including those dependent on black and gray markets, is free of regulation. That makes every economy a mixed economy, so the categories have no meaning. To collate the economic systems of countries in a way that has meaning, we'll collect data on the factors explicitly stated in the standard for several countries. Then use mathematics to sort out the data and transform it into something usable together, and map out the results. Since a Google search for consumer sovereignty rating produces piles of related, but for this problem of model building, useless results, finding values for each factor will require some creative thinking and research skills. Let us start with security. We could use something like military spending. But does paying for military-related expenses actually make a country more secure? Obviously not. So while military spending estimates would not be hard to find, the values found would not well represent the idea of national security. What if we use the World Bank's cause of death by injury, percent of total, to stand in for security? Turns out those values are all empty, as in the World Bank has a World Development Indicator for cause of death by injury, percent of total, but that indicator is just a list of missing values, which in statistics often gets coded as NA. Since that approach would not work, crude death rate seemed like a viable option. Turns out Mexico has a lower crude death rate than the United States. My first guess would be that this is probably due to a greater aging population in the U.S., which would make for a gross misinterpretation of how the U.S. is twice as dangerous a place to live than Mexico. So then turn to life expectancy at birth, total in years. That value turned out to be a much better stand-in for security. Equity was easier to find, as this is exactly what a Gini coefficient attempts to measure. However, using the values required a solution for the logic puzzle created by those values. The first issue is the most simple. Our security values run from 66 to 83, with bigger being better. The equity values run from 25 to 47, with smaller being better. One way to fix this comes from knowing that the equity values can only go from 1 to 100. We can transform the equity index by subtracting each value from 100. Canada goes from 33 to 67. The distance between the values remains the same, but now the values have the property of bigger is better, the same as the security values. Notice anything special about security and equity relative to the other values even after that transformation? They are a lot bigger. If we use the data as it is now, security and equity would count for 67% of the result, while each of the other factors would only contribute 3%, making security and equity the only things that matter. To fix that issue, we can find the maximum value for each factor, then divide each value by that maximum. Now every value runs from negative 0.1 to 1 and represents the distance of that value from the best value for that factor. Now, thanks to mathematics and logic, we have apples to apples and can add up all the values for each country. This shows the values from one solution on a number scale. This image was created by the dot chart function of the R statistical programming language. Google Sheets can create heat maps. Spreadsheet software can be used to create graphs. How the model is presented is not nearly as important as the explanations of the decisions that created the model. The unweighted index allows a comparison and contrast of the data sources. This index is based on sources that are almost entirely from opinion, much more than the fact that all the values cluster in the center, as if all those countries were perfectly equal. Notice how China jumps ahead of Hong Kong. While China does have white markets, black and gray markets still dominate. Claiming that authoritarian China is more market-oriented than Hong Kong is silly to the point of delusional. All of North America drops like a rock, especially Mexico. Venezuela's socialism is no longer on a command economy island by itself. Clearly, all sources are not equal. Matching the index with gross domestic product per person at purchasing power parity shows a relationship between a country's market-to-command orientation and how well off, on average, the people that live under that system tend to be. This also provides ample opportunity to discuss statistical tools like standard deviation, confidence intervals, prediction intervals, and lines of best fit. The modeling required by this project demands the use of skills including research, logic, mathematics, technology, language, and communication. While the project involves 154 high school education standards in mathematics, language, and economics, the main focus is to encourage thinking to solve problems using skills that people have been told are important, but goes much further by showing just how important those skills are when confronting a challenge to answer a question in the real world.